All right, Chemistry B, this is the recording for December 2nd, 2021. Chemistry B, we are going to go ahead and start on page 6 in those notes. So if you will get out page 6 in your notes, I'll wait for you to get there. See if you can do this in about 15 seconds. All right, okay. So the 5 types of reactions we have already covered. The first one that we covered was synthesis. This is when you have 2 reactants that come together to make a single product. That's synthesis. The second, just as a reminder, is decomposition. Decomposition is the opposite of synthesis. It's when you have a single reactant that breaks up to form 2 individual products. Third, we have single displacement. Single displacement is when you have a single element that will displace or kick out or trade spots with a different element in a compound. So in this case, what's going to happen is A is going to displace one of these. Now, if A is like a metal, it's going to replace whatever the metal is. We'll just say that B is the metal, and so A is going to displace B, and then we're left with A, C, and B on its own, right? So the single element came in, kicked out one of the other elements to make it now be by itself. Fourth is double displacement. Double displacement is when you have 2 compounds that exchange ions. And so what you get are 2 totally different products. So what's going to happen is we'll just have A and C switch places. They're going to displace each other. So if A and C switch places, I'm left with the products AD plus, let's see, A with D. So that would mean C would be with B. Okay. All right. And the last one, number 5, is combustion. Combustion, if you remember, we take a hydrocarbon, which can be any combination of carbons and hydrogens. Okay, and you're going to burn that in the presence of oxygen gas to form 2 products. They're always going to be the same, carbon dioxide and water, right? Remember, hydrocarbons have hydrogen and carbon in any ratio. That's why we just have X's, not numbers, down here for our general reaction. Okay, so now we've got that little review taken care of. Hop over to pages 9 and 10 in your notes. 9 and 10. Now you should have already balanced these, and if you haven't balanced these, we don't have our test till next week. But what I'm going to have you do, now you don't even have to have these balanced to answer this question. For each of the items that are circled, so I have 1, 2, 4, 5, 7, 8, 9, 11, 12, and 14, you are going to decide and determine which type of reaction is taking place. Is it synthesis? You don't have to write out synthesis, just write an S. If it's decomposition, just write the letter D. For single displacement, just write SD. For double displacement, write DD. And then for combustion, just write C. You'll write this next to the number off to the side. Okay, I'm going to keep the lecture recording going, and you guys will have about 2 minutes to go through this. You can check with your table partner, but in about 2 minutes, we'll come back together and we'll see if you guys got these right. Okay, I'm going to give you about 20 more seconds on this. Again, you're only looking at the numbers that I have circled. Those are the only ones you're determining type. Okay, let's go through this. We will just start with the first one. Number 1, we have Ga by itself. And I know this is probably really small up on the computer, but you do have these right next to your face. You've got these on your notes. So we're just looking at number 1. Number 1, I have Ga, which is gallium by itself. And in the end, I have hydrogen, which is by itself, which means gallium displaced hydrogen. This one is a single displacement. The next one, I have PdCl2 and HNO3, and I've got a big mess going on. So what I'm going to do is I'm just going to look at an individual element. Let's follow one single element, and let's see if we can figure out what's going on. Apologies, I had a tiny interruption there. So what I'm going to do is I'm going to follow one individual element. Let's follow PD. Let's see what PD did. Let's come back. There we go. Okay. Let's follow PD. So PD is now a Cl2. Later, it's with NO3. Okay, so it did a change right there. And then we see hydrogens with NO3. And later, it's with Cl. So this looks like it is double displacement. Number 4, we have Re, which is a single element, Br2, single element, 2 single things coming together to make one product. This is going to be synthesis or combination. Number 5, we've got AC, actinium hydroxide, and it breaks up into this compound and this water. Okay, so 1 single reactant, 2 products. This one is going to be decomposition, 1 thing breaking up into 2 things. Let's see, number 7, down here, we have SB by itself. Later, we have hydrogen by itself, so that must mean SB displaced the hydrogen. So we're going to say that is single displacement. Number 8, Ra carbon, RaC2, 2 things coming together to make one product. That's going to be synthesis. Number 9, we've got zinc. And then later, oh no, I have created a small disaster. Hang on. Let's see. 1 second. Go back. I cut it off because I'm big dumb. And I'm to the point where I can't just edit this recording because I'm too stupid. So we'll just go ahead and fix that, and there we go. All right, well, let's see. We were on number 9. Number 9, which is actually, you know what? This one is also a big dumb. Man, I'm really stepping in it, you guys. I apologize. I'm not going to restart this recording because that's above my pay grade. So we're just going to say number 9 is an oops. 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 You still can balance it, but there's not a specific type on this. My bad. Okay. Continuing on, let's see if we have any other disasters. Okay, number 11, aluminum and a bunch of other stuff going on. So let's just follow aluminum. Look at aluminum. In the beginning, it's with nitrate, and then later it's with hydroxide. Okay, so that looks like a switch. Sodium at the beginning is with hydroxide, and later it's with nitrate. So that is a double displacement. Number 12, iron by itself, and then later on, hydrogen's by itself. So iron displaced the hydrogen. That one is single displacement. Finally, number 14, magnesium and nitrogen. We've got single elements and then 2 single elements and then 1 product. That's going to be synthesis. So you should be able to look at a reaction and determine what type of reaction it is. And again, I apologize for the mess up on number 9. Okay, go to page 12 in your notes, and we're going to do the first question together. Page 12, very top, your instructions are you're going to write, balance, and identify the type of reaction taking place. All right, so the first one we'll do together. And if you've already done it, you can just check your work and see. So when I read through, I'm going to pick out where my plus sign goes, where my arrow goes. So we got potassium chloride and means plus, silver nitrate, react to form, that means arrow, potassium nitrate, and that's a plus sign, silver chloride. So let's go ahead and just start writing the equation out. Potassium chloride, potassium has a +1 charge, chlorine has a -1 charge, so those together make KCl. Next we have and, which is a plus sign. Silver nitrate, silver has a +1 charge always. Nitrate from your polyatomic ion sheet is NO3 with a -1 charge, which I actually want to write that up here. Ag +1 and NO3 -1, and those will cancel each other out, so you get AgNO3. React to form, there's my arrow, potassium nitrate. So we have K with a +1 charge. Nitrate is NO3 with a -1 charge. So those come together, KNO3 plus, and then we have silver chloride. Silver again always has a charge of +1. Chlorine has a charge of -1. So we just get AgCl. Okay, that's my reaction. Hopefully you're able to see that the potassium changed from being with the chlorine to being with the nitrate. And the silver changed from being with the nitrate to being with the chlorine. So the type of reaction here is double displacement. And if you look at your equation down here, it's already balanced. So you don't even need to balance it further. This one is already balanced. Can't guarantee that'll work with the rest of them, but for this one, as written, it is balanced. So you are going to go through to number 9 on page 12. You can do the entirety of page 12. For each of these, same process. You're going to write, balance, and identify the type of reaction. You can just write the type in the space right here. You should be able to finish page 12 today. Once you finish page 12, you should have everything in your notes completed except the following pages we have not done yet. We have not done 7, we have not done 8, and we have not done the page that says demo day. So those 3 leave blank. Everything else you can finish today. Anything that you don't have done, work on that. If you don't have any chemistry stuff to work on because you've completed everything, you can help people around you, or you can quietly work on material for a different class. That is the game plan for today. Thanks a bunch, you guys.